2003 Oldsmobile Bravada. And the issue that we're having, customer complaint, is a check engine light. This is a 4.2 liter engine, by the way. And so let me get you a shot of the fault codes first before we start. I already know where we're going, and it has to do with the clutch fan, which is actually an electronic clutch fan. Interesting design. So there you go. There is your VIN and your year and your engine. 4.2 liter. Cooling fan speed sensor circuit fault. 1482. Cooling fan speed sensor. This fan was replaced for this fault code last year, and it did not fix the code. Let me get you a shot of what we're dealing with first. We're dealing with just a standard clutch fan from the backside, and you see the replacement parts all nice and shiny underneath the fan itself. On the front side of the fins, there is a black area. That's those cooling fins, and that area of the fan does not turn. It's stationary, and that's where the wires go to. So there are, I believe, 5 wires that go to that, and then that connector extends up to this area on the side of the shroud right here, and this is where we're going to be doing all of our electrical tests. That's the wiring for the cooling fan. Okay, so first thing is there's actually a functional test we can do on the scan tool, and I want to show you that first. So our cooling fan speed sensor, that's the fault code, 1482. Electro Viscous fan is what they're calling this. So we have a test for it. Maintain 1,000 to 1,500 RPM during the test is what it's telling me to do. I'm going to have to sit inside of the vehicle. And I need to change my list here because I need to show you my fan, and that would be under my evap and accessory data. And then what we'll do, we'll customize this list and just pick the fan stuff. So I got desired fan RPM, fan speed, and then my RPM itself. Looks like that's my only fan indicators. And we'll focus on that first. I'll start it up. Very, very noisy. What we'll notice right away is the noise of that fan is actually an indicator that it's fully engaged right now. The viscous part of that fan, it's pretty much locked in. Got real good airflow coming out of that. I believe that is the default. Before we continue, I believe the default for this fan is when the electronics fail, that it is locked into a locked position. In other words, that the fluid coupling is tight, and as a safety measure, if we lose electronics, it makes the fan run at full speed, which is really what I have going right now. Lots of airflow coming from that. I believe that's a safety to protect the engine. So look at my fan speed, it's actually showing me an RPM, so that maybe contradicts the code. You think you need a speed sensor, but I have a speed. It's indicated. I have a fan speed of 1,000 RPM with a actual RPM of 8, almost 900. And you see what the computer wants it to be at. It wants the fan RPM to be at 300. And so there's your issue right there. It is not able to control the fan speed. Now, let me run this at the RPM where the test is telling me to do it. Let's see if I can see as I raise the RPM, that fan's coming up too. Set 1,000 to 1,500. We'll hit test. And what you're going to see is as I increase this number, the desired number is going to increase as well. And at 100% command, you see the desired, it's saying 1800, 1900 RPM. And my fan speed is really not changing at all. It's just pretty much following RPM. I'll hold it at 17 here. Let's drop this back down. So I'm commanding the fan to slow down. There's a 1800 RPM with a 300 desired speed. And you see the fan RPM is not dropping. So I believe our speed sensor circuit is fine. I am worried about the control. So just because we're commanding it to function doesn't mean it's actually functioning like it should. We need to check all of our signals now on the fan itself. We'll be able to use this bi-directional test to aid us in troubleshooting this. All right, so all of my checks, we're going to be back probing this connector right here. It's my first time troubleshooting one of these, and I'm just guessing on the wiring here. I'm not totally sure. I noticed it has 5 wires, so it's a 5-pin connector. So my guess is 3 of the pins are going to be for the speed sensor, and then the other 2 would be the control for the fan. Without a wiring diagram, what I'm going to do next is just go right to my scope multimeter, and we'll go to the lab scope, volts DC, just a single channel is all I'm worried about right now. And I'll let you guys see the digital number here too. My setting is a 20 volt and time base is 100 milliseconds. That's probably too fast. I'm just going down the line here with my connector, and based on what I see, we'll be able to make the determination of what kind of speed sensor this is and everything else. So there is a, looks like some type of 5 volt ref. All right. My guess is this is going to be a Hall effect. We'll see. And there is a 0.5 volt square wave. If that's the speed sensor signal, when I raise the RPM, that frequency should increase. Now, it won't change much because our fan is locked up pretty much all the time. But let me go inside. You guys can focus on the waveform here. Just raise my RPM. If those square waves get closer together, yep, that is your speed sensor signal, guys, and that's the code we were setting, was some error for the speed sensor. The next one down, I would imagine, is the Hall effect ground. It's 0.0. I don't think I'm making contact there. It should be steady. There it is. Nope. That is a gray wire that I am attached to. That looks good. And then the last 2 wires, got nothing. Nothing. So really the bottom 3 wires, I'm not showing anything at all. And my guess on this circuit is the computer energizes it to deactivate the fan. Again, the default is going to be no electronics, full fan speed. I mean, that's what we're seeing right now. So I'm worried about my controls. And so I want to watch these bottom 2 wires. I really need a diagram, but I want to watch these bottom 2 wires when I'm activating the scan tool portion. And it would be nice if Snap-on would give me a dual screen. I know how to do dual screen going through the guided component, but the fact that they're still not letting me do a dual screen, there should be a meter tab right here. Snap-on, if you're paying attention, put the meter tab right here on the scope, on all of the scope settings, so I can go to the scan tool, pull up my scan tool, and then hit my maximize my screen and have my scope set up right where my mouse is in this area. Would be nice. It's about time you do it. Sorry, ranting there a little bit. The command, I just want to make sure my desired is changing. If I maximize this, you see my desired. Okay, the desired is only 750 because my RPM is low. Apparently that's why they're telling you to raise the RPM, but that should be enough because you see my RPM, well, they're matching right now, 700 and 700. I almost need to, all right, you see the command, wait, that's 70%. Let's go back to 100. Yeah, it's based on the RPM itself. So this is the bottom wire. I'm going to raise the RPM. I believe this is one of my control wires. I don't know if it's power or ground side switched or controlled. I know it's going to be pulse width modulated. All right, so my desired fan speed is higher than the actual fan speed right now. So when I go to the scope, I should have some type of signal here. I got nothing on that bottom wire. So I'm changing the command, but nothing on the bottom wire. Let's go to the next wire up. That voltage that's bouncing around is suggesting that I'm not connected to this circuit, or there is an open circuit. I'm definitely making contact. So that, see that bouncing around number? I don't like that. Home tab. Scan tool. See, we're still at that's the door hinge, sorry. That's 100% command. All right, you see the desired fan speed is higher than the actual fan speed. So I should have a command here, I should have a signal. And there you go, I do not. So that test right there, guys, tells you do not put a fan in this. We have no control from the computer to this fan circuit. And so the next test is really to do the same check on the wires at the computer. The computer is not far away. Here's my computer connector right here. So we should be able to do some easy checks right here on the fan circuit. See if we have control here. If we have control here and not there, then we have an open in the harness. And I can do a visual inspection too, which is not a bad idea. But I think to do the test over here is going to be a lot more helpful for you guys when it comes to troubleshooting. But I like visual inspections too. All right, let's pause this for a second and or shut this off. And what I need is a diagram. All right, cool, Hall effect. So there's my 5-volt supply, we checked that. My fan speed signal, the gray white is my low ref, that's my ground. And then if we look at the fan, we have a black wire that's externally grounded. And then the white wire is my control to a fan relay, which is not going to be a regular relay. We're drawing it as one. It's going to be computer controlled. See the white black wire here, clutch control. That's going to be some type of pulse signal to this fan relay. It could be as simple as an engine fan fuse that's blown. All right, let me make sure that we're clear on operation of this circuit. Look, Hall effect signal comes in here on the dark blue wire. That's your fan speed signal. The computer is going to command the clutch control circuit on this white and black wire up to what they're calling a relay, which is most likely a solid state device, basically a module in a sense. And this is going to be a low current input signal, and then what you're going to have is a pulse width modulated signal on the load side of this circuit that controls the amount of speed of the fan. I know it's going to be a variable signal. This is not going to be a regular relay because I can vary the speed with the scan tool. So I'm going to have a square wave signal coming in, and I'm going to have of low current, and I'm going to have a high current square wave signal coming out. And by high current, it may only be 1 or 2 amps, but still that is high current compared to a communication signal, which is what this clutch control circuit is. Okay, first thing I need to do is I need to find this fan relay, which is in the underhood fuse box left side of the engine compartment, and that would be right here. And what I'm looking for, guys, is some type of solid state relay. Yeah, see, they even say in the diagram itself, it says solid state. Let's see if I can show that. Even on the box itself, it says solid state relay, and you see the fan is listed under there. So that is 45. Where is 45? That's these two guys right here. 45 and 46 HDM. Not sure what HDM is, but that's kind of cool that these are both the same relay. That's cool. We can switch them too. And then the other thing would be the fuse, which is a 20 amp fan fuse. Sorry, fuse 20 is a 10 amp, and that would be 28, 26, 22, 20 is right here. Without grabbing my test light, I can actually grab this fuse. I'm just going to pull it and have a look. Ha! This fuse is blown. Let me show you the fuse here. Okay. All right, so is it possible that this fuse blew when they changed the motor before, that it was frozen, something wrong with it electronically, and it blew the fuse a year ago? It is possible. I need a 10 amp fuse. Are there spares in this box? No. Hey, Pete or Tim, can I get a 10 amp fuse? 10 amp fuse. That's for the cooling fan for your sister's car. Yeah, yeah. I'm thinking maybe when it was bad. Yeah. I didn't know that they had separate fuses for the fan.
The water pump did, I mean, that did go bad, the water pump in that fan.
All right, so, you know, there's multiple ways to do this. We could put a short circuit tester in there and whatever. I'm just putting the fuse in for now, and we're gonna redo some of these electrical checks. My belief is the old fan circuit was the issue, and caused that to blow, and it just was never repaired after. But let's do our after numbers now. And the connector, let's be clear on the connector now. White wire is it's power side switch, so we now know that. How do we know? Look at the black wire, goes to ground. White wire, that's pin B, is the power for this clutch, and it's pulse width modulated. So that's the wire I want to go to. That voltage we saw floating around, remember I said that suggests an open circuit, and guys, that's exactly what we had. Okay, so that was on the white wire that we had that voltage that was floating around. And it's a pretty good indicator when you connect to a circuit and you see small fluctuations in voltage. It's a good indicator that you have an open, because what you're really picking up is voltage in the air from the lighting system in this building. And it's actually picking that up. It's like a microphone. Open circuits do that. So pretty cool tip right there. I've talked about that many, many times, looking at the steady line on your screen, shaking your leads, that type of stuff. Okay, starting this vehicle. I expected to see a signal here. Let's go to the scan tool. It looks like we're still not controlling this circuit like we should be. Let's double check that this fuse didn't blow. And it was 1, 2, 3, 4. 1, 2, 3, 4. Nope, the fuse is still good. So it is possible that we need to clear our fault codes. Previously, guys, when I looked at this last week before I finished this diagnosis altogether, I did look at this briefly, and when I cleared the faults, it immediately came back. That may make me shut the engine off, even though it's telling me to. Sometimes it'll let me clear it with the engine running. Let's make sure. Okay, so I cleared the codes, because sometimes you can have a code that affects an output, and it'll keep the computer from energizing that output. I still don't like that my desired is 300 here and that my RPM is high. Let me raise my RPM, and then we'll come back and we'll take a look at this scope signal. I want to see that. I want to see that change. I want to see some kind of a square wave here. different. There it is. Not enough time. Let's get some more time in here. It's a lot louder too, isn't it? Let's go on a 2-second screen and we will peak detect that. Make sure. Now I'll shut peak detect off. Too noisy with that. There's your pulse signal. So our fan speed. Now if I drop this down, there's a time delay there. So it's functional now electrically, but now it's not releasing. Look at that fan speed, it's 2,000 RPM. There it is. I want to see that come all the way down. I'm not sure the mechanics of the inside of that fan or how the viscous part works. I don't know if it's... I want to see that drop all the way down. No, I shouldn't have a fan speed of 1400 right now.
Half of what it is, ain't it? Is that half of your RPM?
Well, you see the desired on the scan tool is 300. That's where the computer wants it to be right now. Let me see what it does at idle. This test you're supposed to do at 1000 to 1500 according to the scan tool. And I don't like that it won't drop. I mean, I know it functions now. There's no command. So the command is there to lock it up. So maybe I was wrong as far as the default goes. No power it runs in a lower speed mode. And if I command this fan speed to increase, you'll hear the fan get loud. Hear the fan getting louder. And then you look at the scan tool, you see the pulsing. Sounds like it's going to take off. It is loud. So it's definitely functional. But hold on. It definitely takes a minute for this fluid to come out. Command is at 0. Finally. Oh, is that noisy, huh? All right, so we are now functional, Pete, but what I don't like is that I can't make this drop down to the desired fan of 300. And as long as this fault code doesn't come back, the downside of this fan that you guys put in, or that her boyfriend put in, is it's just going to be noisy. But at least at this point, our check engine light's not coming back on. Okay. If you have any other issues with this fan, I believe you need to change that fan again. And the reason why is it's not unlocking like it should be. Okay. Make sense?
Yep.
Don't do it, Tim. I saw you take that airline out. You're going to blow something up. He's over here laughing. You're up to no good. Go ahead, blow up your air bottle. Dick.
It would have been really good. I was trying to get it when you were revving it up. He was too slow.
Oh, that would have sucked.
Okay.
All right. Deal. So last comment for you guys watching this. I was mistaken about the default of this. With no power, with no power on this fan circuit, that fan is unlocked, and it doesn't, as the computer starts pulsing this signal, that's when it locks the fan and raises the RPM. So there is some type of a default. I'm not 100% on the data with this. Let me go back to my data. I believe the desired, it should be matching my fan speed right now, and I think that this aftermarket clutch is just not disengaging mechanically like it should. So my fan speed is 720. Here, let me customize this. This is not in the functional test mode anymore. This is regular scan data. Desired fan speed, RPM. Yeah, and you see the desired is 300. The computer wants it to be at 300. And without looking at enough of these, I don't know if that's much of a problem, but this is keeping the light off now, and I don't like it. I don't like that our desired fan is 300 and our actual fan is 720. But here's what we know. Electrically, when it is off, as you can see with the scope, electrically, when this circuit is off, that fan should completely unlock. Those pulses got wider, and as I commanded the RPM to be higher. So that's how we know, electrically speaking, our circuit is working now as designed. Mechanically now is the issue here, and I'm not worried about it. As long as this light doesn't come back on, we should be good. But if any of you guys watching this, if you have issues with a noisy fan, then I think at this point it would be replace the clutch fan again. But there's still a question in my mind that this may be normal and not to worry about it. So, but electrically speaking, this is a power side switch circuit again, and very easy to troubleshoot actually. Basic circuit design. This would be section 3 material for you guys following along, or chapter 3 in my book. Power ground side switching, output controls, and then the Hall effect, the speed sensor that's down here, it's no different than checking a camera crank sensor. Pretty freaking cool. Here, I'll give you guys one more little piece of information, and that would be our Hall effect. Since I just mentioned it, my Hall effect signal was my second pin down, that's the 5-volt ref. The blue wire is the speed signal. And with the key on and plugged in, if we disconnect the connector, it's, all right, you guys following along? This is chapter 2 information in my book. This is a pull down type switch input. You'll also find this information in chapter 21, which is all of my ignition inputs. Troubleshooting this circuit, very, very easy. Pull down design Hall effect signal for the fan, power side switched output for the control.